Batteries are all around us in almost every device. Today's world is fully electrified. Many devices, such as a mobile phone, laptop, MP3 player, but also a car or an airplane, take their energy from the battery from the so-called galvanic cell. We all know saying he was out of battery or out of energy, and later, I have to recharge my battery, I'm tired. We can see that batteries could also in our slang English. Alexandra Volta built the first galvanic cell, also called the Volta cell, in 19th century using research on material differences. He connected the individual cells in series and built the first several volt battery, the so-called volt column. The galvanic cell works on the principle of converting chemical energy into electrical energy. Simply, we have two electrodes made of different materials, zinc and copper. After immersing the electrodes into the electrolyte, in our case sulfuric acid, H2SO4, a voltage arises between them due to the difference in materials. We call an electrode immersed in an electrolyte a semicell. Electrolyte is a conductor in which the passage of electric current is made possible by moving charged particles, ions. On the other hand, in metals, the current is formed from the movement of electrons. The zinc electrode is now the anode reacting in a closed circuit with sulfuric acid so that the zinc oxidizes. At the same time, hydrogen is released at the cathode. The zinc dissolves and the freed electrons are guided by the attached metal conductor to the counter electrode, to the copper cathode, and on the way through the circuit, the electrons perform electrical work, for example, they light up a lamp. Batteries are divided into two groups, that is, to primary and secondary cells. An example of a primary cell is Leclanche cell. It is usually used in large small cells, pencil type or micropencil type batteries. It is also called a dry cell because the electrolyte isn't a liquid but a paste. The anode consists of a zinc cap, which is also the outer casing of the cell. The cathode consists of a powder manganese oxide, MnO2, which is mixed with the powder carbon for a better conductivity. A carbon rod placed in the axis of the cell is inserted into the mixture. The electrolyte consists of an aqueous solution of ammonium chloride, NH4Cl. It isn't free in the cell, but it's absorbed into the positive electrode into a powdered mixture of a carbon and manganese oxide. Between the positive electrode, the powder, and the zinc cover, there is a separator made of absorbent paper to prevent direct contact between the electrodes and at the same time allow the passage of the electrolyte between the electrodes. The advantage of such cell is its low price and easy portability. An electrolyte can be a substance in a liquid, solid, or gaseous state. For example, the liquid solution does not always have to be the same substance for both electrodes. We can use a different electrolyte for each electrode. In that case, both semicells are connected by a salt bridge or a plate that enables a conductive connection but prevents mixing of the two solutions. The primary cell is, for example, a silver zinc cell. You can find it in the flat battery in the watch. A zinc air cell is, for example, in headphones. The lithium cell can be found, for example, in chargeable batteries. The secondary cells include rechargeable batteries, accumulators, for example, car batteries, lead accumulators, which are the oldest in terms of development. These batteries can be returned to their original charged state after being discharged by a reverse chemical reaction after the supply of electricity. A representative of this is the battery in a mobile phone, for example, a lithium polymer battery. The electrolyte is in the form of polymer, so it charges quickly and has no memory effect. This means that we don't have to discharge before charging, but the condition of a safe transport
for the accumulator is the stability of the electronic materials so that they don't increase or decrease during charging or discharging. The future of batteries is bright because scientists are trying to develop batteries smaller and smaller and with higher and higher performance, and at the same time the batteries of the future will be made of cheaper and more accessible materials and will charge significantly faster than today.